Hi everyone, today I will be presenting our work, Semantically Diverse Path with Range and Origin Constraints. Here is the outlines. First of all, motivation. This figure presents a regular road network with 9 points of interest located on it in 3 different categories. Also assume we were a visitor standing at the cross with a preference on POIs and having constraint on traveling budget. For instance, we want to visit at least 1 POI in each category, and the path cannot be longer than 1 mile. Where should I go? The source east direction does not have park, which was labeled as green elephant in the figure. The source west direction has all 3 categories, but the path is too long. Eventually, the north one satisfied all the preference. However, this query actually had been solved in another paper last year. Now, what if the sightings is we no longer know the starting location? Instead, we want the system to recommend one from a set of user-preferred origins. For instance, if we have 3 possible origins now, presented as the red cross in the figure, the one in the dashed circle is another option for us. In other words, the problem now is, given the preference on POI, traveling budget, and origins, recommend a path as well as the origin. To answer this query, we used 3 methodologies in this poster. The Dijkstra and the random walk are classical and kind of straightforward. Because of the time constraint, we will skip them. But we will briefly discuss greedy Dijkstra. Consistently speaking, starting from each origin, we utilize Dijkstra algorithm to find the next nearest POI desired in the preference. Then, from that POI, we find the next nearest POI. So on and so forth until we collected all the necessary number of POIs in each category, or we terminate the whole process. Here are some numbers in our experiment. Because there's no such POI road network dataset, we use the data from OpenStreetMap and TripAdvisor and construct one. The code and the generated map can be found in this Git link. Moreover, we used 576 hotels in Manhattan area as the possible origins. This table shows the result. Given 177 different POI preference and 6 distance budget from 500 to 3.5 kilometers. We also conducted the experiment in terms of the number of origins. We can observe that the greedy Dijkstra always achieved the best result compared with the other 2. For random walk, we actually allow triple times than the others, while it's still always the worst one. To conclude, we introduce a novel range query in this work, which considers the preference not only the semantic diversity, but also the origins. There are 3 baselines experimentally evaluated in this work based on a real-world dataset. All the source code, as well as the generated POI road network, are publicly available for the potential value for future research. Regarding the future work, we plan to incorporate optimization criteria like the distance, like the path length. We also want to explore some indexing to couple semantic diversity with the path exploration. Thanks for your time.